Next thing we're going to look at is bleed leak detection. So in these systems, we've got a bunch of hot air moving around. We want to make sure that we don't melt things or cause structural damage. And so as part of the flow portion of it, we're going to monitor for hotspots. So you've looked at, when we looked at fire overheat, you looked at things like spot sensors and Fenwall loops and kitty loops, that kind of thing. You know, one application is to look for fire, you know, in like an engine or something like that. And those are fairly high temperature loops. We can use lower temperature loops, loops that activate at much lower temperatures to look for bleed air leaks. Specifically in the areas where the bleed air has not gone through any kind of a cooling process yet. So they're similar to those. They can be coaxial, which is your Fenwall loop. Dual element is your kitty loop. Kitty and Fenwall both make both types of loops now too, by the way. They're just named after who developed them first. So they run alongside your ducts, and one way to make these work is, you know, if you have a loop, it's only going to be able to monitor one side of the duct. So in critical areas, you'll often see what are called double wall ducts. So if I have a duct, if I look at it, if I were to cut it in half, or if I were to cut it, you would have your main duct on the inside, and then it would actually have a second duct around the outside of it. Oops. Okay. So the air would be traveling through that inner duct. And this outer duct, there wouldn't be anything traveling through it, but it would have little holes on a certain side. And so then when we run our loops next to it, we would run our loops right next to, you know, in line with those holes. So if you looked at one of these from the outside, you would have your duct and it would have a bunch of holes along the length of it. And then the loop itself would be run roughly right along here, right next to them. So if the air leaks out of this inner duct, if you get a crack in here, even if it's on this side, air leaks out, it's going to fill this space here, and it's eventually going to come out and blow on your loop. Okay. We can also do that with spot sensors. So instead of running a loop along the side of our duct, we still use a double wall duct. And now we can put several spot sensors along it, you know, pointed at each one of these. And they wouldn't be this close together. In real life, they're probably, you know, if you have spot sensors like this, you might have a 6 or an 8 foot duct with one hole, you know, double wall duct with one hole in the middle with a spot sensor there, and then another 6 or 8 foot duct. The other spot they'll put these is at the joints where two ducts are connected together. Most of the time, this ductwork is joined using V-band clamps. And a V-band clamp is when you have two ducts, they have a flared end on them. So the end of one duct looks like this. You know, if that's your duct right there. Your other one is going to be the same way. Look like a couple feet kind of pointing at each other. And then there's no, some will have a seal, some won't, but there'll be a clamp that runs around with a channel shaped like this. And as we tighten that clamp down, it's going to squeeze those two ducts together. When you do your starter generator inspection in engines class, you're going to work with one of these V-band clamps. We use the same thing to seal ductwork together. So then you could put your spot detector. Again, if you use spot detectors, a common leak spot is here. You would put a spot detector here, or you would run your loop around that area if you use a loop style, and to make sure you don't have a leak at a joint. So these are going to be monitored by some kind of a modern aircraft, a computer system that can do built-in tests and can monitor the health status of the various loops and or spot detectors. Older ones were wired all together. Oftentimes it'd be one loop loops would be in parallel, or they'd be, one loop would be in series with another. Now they hopefully are going to be discretely wired, so if you have a failure, it's easier to figure out which one it is, whether it's loops or spot detectors. This pneumatic system is then going to feed into our environmental control system.